What a board! Lots to talk about on here. This is dealing with the type of electricity that we get at home, which is different to the type of power source that we've looked at so far on all the other boards, where the electricity was provided through batteries. What happens there is the current will flow round the circuit and then stop. On 2 or 3 of the boards we looked at, including the last one, we had a switch where we could reverse the flow of current. So we could either have it flowing one way or we could have it flowing back the other way. With the type of electricity that we have coming into our house, it's doing this forward and back automatically 50 times a second. And we can see that with the aid of this pocket oscilloscope, which has a graph on it, and up and down we've got voltage, this centre line being 0 volts, and anything above being a positive voltage, anything below being a negative voltage, and we've got time going along the other axis. So when I switch the board on, what we're getting is this wave showing that the voltage starts at 0, climbs up, and then drops down below the 0 point to a negative voltage and then comes back again. And the cycle of that is 50 times a second, 50 hertz as we call it. Now that 50 hertz is within the audio range, and that's why I've got a speaker plugged in here. And if I press the button, we can hear the note that 50 hertz makes. Now, why do we need this type of electricity? Well, the key is this bit here, the transformer. And this works in the same way as the last board. We've got 2 coils of wire wrapped round each other. The first coil is connected to the supply, but this time the voltage is changing the whole time. It's growing, shrinking, going negative, going back to 0. So the magnetic field that this coil is generating is constantly changing. And what we said was that if the field is changing, it can invoke a current in the other coil next to it. Now, if the coils are the same size, the voltage we get out in this, what we call secondary coil, is the same as the one going in. But here, this first coil is longer than the secondary one. And that means the voltage we get out is less. Here's the voltage going in. We've got about 12 volts going in. And here's the voltage coming out, which is just under 2. And these transformers are used all over the journey that the electricity has from where it's generated to our houses. And the reason for that is it's easier to transport electricity at really high voltages, but we can't use it at high voltages. So at the power station, it's changed. It comes halfway across the country, and then before it enters our house, there are these transformers to take the voltage down to something that we can use. So the main reason why we use this alternating current, as it's called, is so that we can change the voltage through transformers. Now what have we got on the board here? We've got our old friend, the bridge rectifier. Now if you remember what the bridge rectifier did, is here's our input, and what we said was, regardless of which direction the current was flowing, this point of the bridge rectifier would always be positive, and this point would always be negative. So if we follow this wire down, it comes across to the bottom here, and we follow this wire here, we go to the top. So if I unplug the oscilloscope and I plug it in here, what's happened is we no longer have anything below the centre line. Everything is above, because where it was going negative, that dip has been turned into a little sort of hill. So now we've got 100 hills per second rather than 50 hills and valleys. Next to it, what we've got is a light, and we've got a small electrolytic capacitor. Now if we switch that into the circuit, as the voltage climbs, it's going to charge the capacitor, and as the voltage starts to drop, the capacitor is going to take over and discharge when it was going down to 0. So now it's always above our centre line. I'll just press the OK because it will hold that still. We can see that it drops a little bit as it discharges, but it's smoothing it out. It's not dropping down to 0. And if we switch on the bigger electrolytic capacitor, what we'll see is it almost flatten out completely. So what we've produced is a DC current. We've produced something similar to a battery where we've rectified it so we don't get anything negative, and then we've smoothed it out so it's not dipping at all. It's a little bit wobbly, but it's pretty good. So this is how a power supply works to charge your phone, for example. It's taking the AC electricity that we get into the house and turning it into a supply which is suitable for your phone, similar to a battery. So there we go. AC to DC conversion, oscilloscopes, and most importantly, a transformer.